Hello.
Hi, Mr. Rosenthal.
Hello.
Hi, Mr. Rosenthal.
Hello. Hi, Mr. Rosenthal. Hi, Mr. Rosenthal. Hi, Mr. Rosenthal. Higher, Mr. Rosenthal. All right, there's the review. Start taking a look at those problems. That's what we have to get. Perfect scores, folks. Some of you that are on the border of a higher grade, you got to ace this. You got to take really good notes. Your test is going to look just like this. Notice this is 3B. You're going to be taking 3A. The questions are not easy, but once we go over it and you know how to do it and you ask sufficient questions over the next 2 meetings, this meeting and tomorrow, Friday, you should have all the notes ready to go with your formulas, and you should have an army of resources available to you to ace this. Calculator.
Are we gonna be able to take more time on this?
On what? On the test or
On the test?
You get the same amount of time. Why would this one be more time than the last one?
Is this the last test?
Probably,
Okay.
but you never know.
All right.
Starting to run out of time here.
Mr. Rosenthal, also you could just like copy what the question says and then plug in different numbers to study.
Mm-hmm. Exactly. I hope everybody heard that. Can you say that again, Jasper, for everybody?
What you can do is that you can copy down the question, but plug in different numbers so for practice.
Yep. Period 2 quizzes are all graded. I'm going to try to get to all the period 3s today. So you can see, you know, you can go back to that as well and use that as a, what did I do wrong? How do I do it right the next time? And as soon as we get our normal participation up to 60 plus, I'll say some of the things I noticed in the quiz that you want to look out for on the test. Just a couple things. They look pretty good for the most part. I gave a ton of extra points for the quiz. As we get near the end of the year, I really want to give everybody that benefit of the doubt, that opportunity. I want you to leave happy, you know, but I also, you got to earn it, right? You got to work for it. Some people did not take advantage of the extra, you know, they didn't. You really got to treat this as put everything you can into this test. Okay, last ditch effort for everybody, even if you have an A. Okay, it's 10 o'clock. We only have 40 participants. I will start the first problem and then let me know when we get to 60 and then I'll talk about the quiz. It looks like we're gonna take 2 days for this review, so we can take our time.
Wait, Mr. Rosenthal, is this a review or is this the actual test?
This is a review.
Okay.
Hello. We always have to review first, always.
I think it's because the review looks a bit different now.
Well, it's because for lack of time to create a whole thing, and we're not retaking this, so why not give you what would have been the retake? This would have been the retake.
Oh.
So this is going to look just like your test. Okay? So these numbers are going to work out better than my numbers would have been if I did a review. Okay? This is going to be even more closely than my review. This is going to be the closest you could possibly get to what the test looks like.
Yeah.
Okay, so I'm trying to do this for you guys. Now listen, as we go forward here, you might want to print this out later. If you don't do it now, but take notes so that number one goes with number one, you're studying it. Then you have that right next to your number one when you take the test Friday. And you can look at all the work you did if you need. Of course, you should try to not need it, but when you need it, if you try to rely on it too heavily, you're going to run out of time. So you try to do the problem on your own, maybe glancing at your notes, but don't try to rely too heavily. But there's really no excuse if you have all of these problems are the same pretty much as on the test. Pay attention to what we do. Ask questions if you don't understand what we're doing. Make sure you understand how to do it. Okay, let's start. Almost to 60. I'll just go ahead with it then. What I saw in the quiz. What I saw in the quiz was a couple things. There were a group of students that didn't read the directions. It said area and circumference for the first 4 problems. I had students that were alternating. One time they gave area, one time they gave circumference, one time they gave area, or I had students that just gave circumference or just gave area. There were lots. So you didn't read the directions. And if you were not sure what they were asking, if it seemed weird to you, but you just didn't say anything, that's a mistake. You need to ask. That's why you come on Zoom to do that. You come onto Zoom while we're taking the test. You say, Mr. Rosenthal, do they want both the area and the circumference? They did. So people lost easy points that they could have gotten if they just would have read the directions or asked if they weren't sure. So please, when you do this test, even now in the review, if you're going to have a question on the test, you really should have the question now, because this is what the questions look like. So pretend like you're taking the test here and ask questions as if you were on the test. So you don't need to ask them on the test. Okay, and then second, there were a even smaller group of students who got an incomplete because they showed no work. And I warned you. I warned everybody. You need to tell me what you put into the calculator. But I had students that just submitted answers, and they missed out on that opportunity to get all that bonus credit. And you can't redo it. And I'm sorry. But you didn't listen to what I told you. You must show all your work. I had a couple students that showed a little bit of work and I let them get away with it. But on the test, I'm not. I'm going to give an incomplete. If it's not sufficient work. So I am warning everybody right now. I hope, get your ears open, listen. You must show every little detail of work possible so that I know what you were doing. You cannot just say I plugged it into the calculator. You cannot just say I used this formula. You can't just say, okay, pi r squared, and then you put an answer. That's not enough. It needs to look, if you want, the work that I do for the problems is an example of the work that I need to see. Okay? Oh, hold on, Miss Huff is calling. Hey.
Mr. Rosenthal,
Hey.
where can we down the
Oh, give me 1 second. I'm on the phone with Miss Huff. I'll be right with you.
Okay.
No worries. I heard that. I saw that. Well, fortunately, I don't have any students that need that. It would be she's not one of my students. So we're okay right now. But in terms of the closed captioning, we have to maybe contact Zoom and see what they have available. Oh, they're having a meeting? Oh, you mean for that meeting? Oh, okay. Well, we can try to call Zoom and ask them what we have available for that. If not, then, we have the resources that we have available in this time of crisis. We're limited. So, yeah. Yeah, I mean, and what we can do is we can record it. We can put it up on YouTube, and then somebody maybe can translate it in person for her, Mm-hmm. Okay, we'll talk after. Okay, all right, bye. Sorry, everybody. We have to make sure that everybody can access all of these Zoom meetings, right? So, all right. So what I was saying is you have to show all your work. You cannot just put a formula and say, I use this formula and here's my answer. If I see a formula, then I should see below it what you substituted. See that? All right. So there needs to be, I can follow your work. I still had 1 or 2 students submitting their test sideways. Submitting your test sideways aggravates me. You should know that. It's aggravating to me. Right when I see it, I say, wow, did this student proofread it? They're not really thinking about what they're doing. You know, I need you to proof your pictures before you send them. 1 page, please, 1 page. I still have students doing 2 pages. I can get through 2 pages, okay, but it is better as 1 page. Ask about Cam Scanner with your friends and how to do it correctly. It should be submitted as a PDF. Some of them are coming in as this HEIC document. Maybe that's from Google Doc or something, I don't know. But all you have to do is send it as a PDF, and it's easy to view that way. All right, anyway, let's get down to what we're supposed to be doing. Number 1, the circumference of a round swimming pool. Draw it. That would be a way to show work, is to draw a diagram. I know you're thinking about the problem. The circumference, right? And then so when I see an answer and you don't have any of this, you're not showing me that you're actually thinking about the problem. And saying I did my work on another paper and I threw it away, that's not acceptable. Then you don't get the credit, okay? So you've been warned. So look at my thought process is going onto the paper, onto the board. Okay, so the circumference is 301.44 inches. What is the diameter? That shows that now when a teacher reads that, they know, oh, you wrote down the information and you're gonna go try to find that. Okay, and then I should see a formula maybe. Circumference is equal to pi or d pi. Okay, circumference 301.44 is equal to the diameter I don't know, and pi they told me specifically to use 3.14. So should I use my pi button? No. No, because the directions specific, you have to read the instructions. It told me what to use, so then you must use that. Okay? How do I solve for d? Easy, divide. And d is going to equal whatever that is on my calculator. Now look at all the work that I showed. Okay? I get it. You can do it in your head. I understand. That's not acceptable. You cannot submit it and just say you did it in your head. I am happy for you that you can do it in your head. That's not what gets you credit though. 301.44. Oh, I'm not even, you guys even seeing what I'm doing? I didn't even unshare the screen. I drew a circle. I said what the circumference was. I said we're looking for a diameter. I drew the formula. Circumference is equal to d pi. I substituted, the circumference was given. Pi, they said you have to use 3.14, and then I divided. So in my calculator, I do 301.44 divided by 3.14. 96. If I use the pi button, I will not get 96. And then I'll know that you did not follow the directions. And I want units. This is the answer. Take good notes. You can follow the same progression. Now, what if it gives me the diameter and it asks for the circumference? It could switch it around like that. Okay? They might
multiply the diameter by pi.
Charlie, change your name, please. Okay? So if you want to practice, make the diameter 96 and see if you can calculate that as 301.44. Okay? Any questions about number 1? Number 2. Number 2, the diameter of a swimming pool in exercise 1, the diameter of the swimming pool in exercise 1 is reduced by 25%. How does this affect the area of the pool floor? Okay, so what are they asking me to do?
They're asking you to reduce the area by the diameter by 25%, and then solve for the area, and then do it regularly and compare the answers.
Yeah. You think so?
Yeah.
Like a change in how it's like how does it affect the area, like by how many times, or like by how many like places?
I guess you could show reduce it by 25%. What does that mean to reduce by 25%? Well, we have the diameter from number 1 is that. What is reducing by 25% mean? It means to take
multiplying by 0.75.
You can do that. Multiply by 0.75 is good. 75%.
Or divide by 4 and then subtract your answer by 96.
Yeah.
I mean, subtract 96 by your answer.
It means cutting this into quarters, right? 48, 24, okay, and then 72. Okay? Each one of these represents 25%. So if I reduce by 25%, I end up there. That's one way to think about it. But yes, multiplying this by 0.75 would do it. Okay, so now if the diameter is now 72 instead of 96, how does this affect the area of the pool? Well, if the diameter is 72, then the radius is what?
36.
36.
Okay. All right. What did the radius used to be? Or when the diameter was 96, what was
it used to be 48.
48.
48. Is this 75% of that?
Yes.
Yeah.
Yeah.
Yes.
Because 48 broken into quarters is 12. 12, 24, 36, 48.
And the rest of the numbers are constants.
Why is 75% of the diameter also 75% of the radius? Because they're both one-dimensional.
Mm-hmm.
Okay, but when we go to area, how will that affect the area?
It will
decrease by more because we're gonna square it.
Okay, well let's find the area here. Okay, the area here is 48 squared.
7,234.56.
I'm going to leave it in terms of pi. 2304 pi. That's pi r squared right there. This one is 36 squared.
So it's 1,296 pi.
But how do you compare those then?
You subtract the 1,296 from the 2,304, and then you divide that by the 200.
Why do you want
the 2,304, and then you find a percentage.
So you're looking for the percent increase, or the percent decrease. You're looking for the percent.
Well, it's not 75% anymore.
Yeah, and the percent decrease is about 43.4%.
Okay, so you want to see how much it decreased by. All right, so 2304 minus 1296. 2304 minus 1296.
So this is just referring to the problem itself, not like in the general concepts.
The difference between these is 1,008. That's what I was asking you in the beginning. It's 1,008 pi divided by the original amount. So now we're going back into percent decrease. You divide by the original amount. The pi's cancel out. So it's 1,008 divided by
2,304.
And you get about 43.4%.
Okay, So you're saying a decrease of 25% in the diameter gave us a 43.75% decrease in area. That's what you're saying?
Mr. Rosenthal,
Yeah.
do you want us to use the pi button or 3.14 for number 2?
No.
No, what?
We're leaving it in terms of pi. You don't need to calculate anything with pi in it. You just leave
It just
pi.
makes it more difficult
Okay.
because they
Now-
cancel out anyway when you find the percentage.
How could I have done this problem differently? How can I have shown what happens when you decrease something in one dimension? How does it affect the next dimension? Okay, so if I'm only getting 75% of something, right? If I have 75, if I have the radius squared is my original, pi r squared. And then I do 75% of r. 75% of r, and I square that times pi. And then I want to look at the difference, so here's regular versus 75% of that. The pi's will cancel out. Okay? What is 0.75 squared?
0.5625.
It is 0.5625. Okay? That is what percent of the original area you're going to have. If you're going to have 75% of the radius, then what you're going to have is you're going to have 56.25% of the area. By the way, what happens when you add these two together?
Equal 100%.
100.
This is how much you lost. This is what percent of the original you still have.
But my answer was the pessimistic version.
But look, I didn't have to do any of this work. See that? It didn't matter what the answer in problem 1 is.
It was not about the decrease. It was more about.
It's not about the answer to number 1. It's about what has to happen no matter what the radius is.
Okay, I had a question on the second part, on the second answer.
In the general concept.
So there's going to be 2 ways to answer this. Either of these could be the answer.
It's the difference between glass half empty, glass half full.
Correct. Yes. So you can say that the result of reducing the radius by 25% is that you are going to have 56.25% of the area. Or you can say what you lost. If I lose 25%, then I will have lost 43.75% of my area.
But you said the one where
Take good notes, folks. Take good notes because I'm telling you how to show this to me on the test. This is lost area. This is percent of original area. That's why there's 2 different answers.
And you said the percent of original area is easier to find. And can you just walk me through how you would find it one more time?
Yeah, this is 75% of the radius. Now you have a new radius, but the formula is still the same. So it's that radius now squared times pi.
That's why, like, you don't have to plug in actual numbers in order to find, like.
When I put it over the original, which was just regular pi r squared, that is going to give you a percentage, right? Like 9 out of 10, 8 out of 10, 75 out of 100, right? That gives you the percent that is of that. This out of that is a percent. Okay?
And so what you did was you took the actual radius and then you squared it and then you just divided by the numbers?
Well, what I did is I said my original radius is here, r. My new radius is 75% of r.
Okay.
Wait, Mr. Rosenthal, 2 things. Was the problem asking, like, because I'm trying to rephrase this in my review, so was it, like, if there was a 25% decrease of the diameter, how does it affect the area?
Yeah. How does it affect the area? Well, then the new area will be 56.25% of the original area. The new area will be 56.25% of the original area. That's exactly a perfect answer on the test. Or you can say, or you could just do this. Not even a full sentence. 43.75% lost area. I will interpret that correctly. By reducing your diameter by 25%, you reduce your area by 43.75%. That's a way to say it as well.
Did you just substitute? Okay, so for the equation, the 0.75 r squared times pi over r squared times pi.
Van, what's this 0.75?
That's how much? That's what percent?
That's 75% of the original radius.
Yeah, and so did you just substitute the radius for an actual number? Because then how did you divide it? Am I missing something?
Okay, let me.
Because it's the same exact number.
Let's play this out. 0.75 r squared is this. It's 0.75 r times 0.75 r times pi, right?
You can think of it as
0.75 times 0.75 is 0.5625. R times r is r squared times pi. Now remember what this was over. This was over r squared times pi. Well, pi over pi cancels. R squared over r squared cancels.
because they're the same number.
It just leaves you percent.
You can't have two different numbers for
Let's simplify the problem even more. If you're going to be left with 75% of the diameter or the radius, then the area is just squaring that number. So if you want to get rid of everything else, get rid of all of this, if this is what you're going to be left with, 75%, then for the area, since it's two-dimensional, diameter is one-dimensional, once you say area, then it's the square of that. If you want to lose 25%, right, then for the area, you're going to lose 25% squared is what you're going to lose. That's the other way to do it. That will give you this number, right? Okay. If you do 0.25 in your calculator right now, squared, it's going to give you this number. That's the lost, that's 0.25 is 25% lost, right? So the area is going to lose that squared. That's the easy way to do the problem. 0.25 squared. Oh, that's not 43.75.
Mr. Rosenthal, will this problem, will the 25% thing, will it be the same no matter, will it be the same no matter what, or will it ask, what if it was a 75% decrease or a 50% decrease?
Ask me that again.
So if on the actual test, will there be a different percentage decrease, or will it still be 25%?
It might still be 25%. I don't know. It could be an increase. Oh, okay. It might be an increase. On the test, it might increase it. So this number would have to be 1.25, right? 1.25 would be an increase. And then you would square that number. Then you would square that number, and then you would get something more than 100%. So on your test, you might get more than 100% of the original area.
Why do you square 0.75? Is it because it's the radius?
It's 75%. So you have two things. You have your original radius, and you have your new radius. Your original radius is just r. Your new radius is 75% of r because you decreased your r by 25%. Now, did it say that? No, it said you decreased your diameter. But when you decrease your diameter by 25%, then you also decrease your radius by the same.
Yeah, I get it.
Okay? So what you're going to do on the test, if they say increase your diameter by 25%, here's your r, your new R will go up by 25. So you'll have 1.25 R.
It's just basically the percentage squared.
What happens?
Yeah.
What happens when you square that? It's going to be 1.25 squared, and everything else cancels. So, well, I don't want to give away the answer, but you guys can take that to the end, and you'll already have an answer ready to go for your test, if that's the problem. Okay, we got to move on. So you have a ton of notes here now. Ask questions if you need. It's a difficult question.
So the answer would be 25% squared.
No, that was not the answer. The answer was, there were two answers that I just erased. One was that your new area will be 56.25% of the original. Okay? The other way you could have said it is you would have lost 43.75% of your area.
Okay, so it might be smarter to do the math than, it will be smarter to do the math than just like have a trick to figure out the answer.
It depends on the person and your level of understanding of it.
Okay.
As long as you understand the math, then you can do the trick. As long as you understand both.
All right, let's go on to number 3. The diameter of a ceiling fan, blade tip to blade tip, so you might draw it. Okay, is 90 centimeters. Okay. So you should be taking notes. As I'm writing it down, you're writing stuff down. Draw your own diagram. About many whole revolutions, it should say how many whole revolutions does it take for the fan to move 1,000 meters? Okay. So we want to know the circumference of it then. And you have the diameter. Okay, so let me start the problem. Okay, so I have a fan, blade tip to blade tip. This is going to go around in a circle, right? The fan goes around in a circle. So this distance, this 90 centimeters here, is the diameter. Well, it's great for circumference because the circumference is equal to the diameter times pi. Okay, now this does not say what to use for pi. So guess what I'm going to use? Pi button. All right. Actually, you know what? Just to make it always the same for everybody, let's just use 3.14 for pi. Write that down right now in your notes. Put that in your notes. Use 3.14 for pi as a default. And that way we'll all get the same answers. Okay, so let's go ahead and do that now. So circumference is about 90 times 3.14. So what does that mean? It means when the fan turns one whole time around, if you mark this point, let's say you let your 4-year-old get the marker and mark it up. By the time this goes around one revolution, that distance traveled is 282.6 centimeters. Any questions so far?
So does it say that in the problem, does it say after 1,000 revolutions?
Okay, now this problem is tricky in a couple ways. It wants to know when the fan has traveled not this many centimeters, but 1,000 meters. Put an asterisk right there.
Oh.
We need to convert it into centimeters.
Danger.
By multiplying it by 100. Or we could convert the centimeters into meters.
Yes, it doesn't matter.
Yeah.
What I'm going to do is I'm going to say there's 100 centimeters in a meter. So I'm going to
Wait,
make
100,000 centimeters.
Yes, this would be 100,000 centimeters. Now they're both in centimeters.
That's good.
Okay.
So then you just.
What they want to know is how many revolutions, this is one revolution here, go into 100,000. And it says
So then you just divide.
That's right. So I'm going to do 100,000 divided by 282.6. About 353.9.
Yeah, but it says how many whole revolutions.
Right. So we're going to round it to the nearest whole. It's about 354.
Miss
Always. Can you abbreviate revolution to revs?
No. Okay, there.
Mr. Rosenthal?
Yes.
Did you just divide 100,000 centimeters by 282.6?
I did.
Okay.
It's interesting to think about how far a point on the end of your fan blade has traveled. And that probably doesn't take very long because the fan is going so fast. It probably does not take a long time to reach 354 revolutions. And then to think that it's traveled 1,000 meters in that time, that's, wow, interesting thought.
Yeah, this fan travels 40 revolutions per minute.
Yeah.
Yeah, enough.
Let's go ahead and move on to part B. So already, you guys are, if you're not taking good notes, you're going to be pressed on this test. Okay, if the fan rotates at 40 revolutions per minute, all right, we know how many revolutions we need to achieve now, 354. Okay, if the fan rotates at 40 revolutions per minute, how long does it take to move the 1,000 meters? Well, that's an easy follow-up. Okay, so it's going to go 40, I'll let you do revs here, per minute. How long does it take to reach 350? It doesn't say this. It says how long does it take to get your 1,000 meters? But we already know how many revolutions that's going to be. And you're going to do 40 of them at a time, every minute. So it's just this number divided by 40. So 354 divided by 40, 8.85. Now let's see, about how long does it take? 8.85 minutes or 8.9, let's round to the nearest whole, about 9 minutes. Okay? It takes about 9 minutes to reach that many revolutions. So the second follow-up question, once you got the first one, it's just a calculator. I need to see this though. I need to see what you did. This right here shows me that you were thinking about that. Just going from here to here does not mean that you were thinking about it. I don't know what you did, how you got that. Okay, you might even show me 354 and put it over 40. Show me that. You might do 100,000 and put it over 282.6. Go ahead and do that just to make sure you've shown all your work, okay?
I have a question.
Mm-hmm.
For the first part, wouldn't you round up? Because it was 354.2 was what I got, so it's not exactly like 1,000.
I got 353 point something.
I must have did my calculations wrong.
Did you use 3.14 for pi?
Yes.
Okay, let's do that. So that's the circumference is 90 times 3.14. You get this, which is what I have here. Okay, and then you want 100,000 divided by that. Okay, so that would be that. Not 354.
Oh.
Okay. Maybe when you were doing 0.6, you slipped and hit point something else. I don't know. All right. Any questions about number 3? Be careful with the units. Leave yourself little messages right now in your notes that tell you to look out for certain things that you can make a mistake on.
So, Mr. Rosenthal, what I'm doing for my review is that, so I'm leaving, like, I'm writing down the processes, but I'm leaving the numbers blank.
Mm-hmm.
Would that be, like, good? So then, like, when it comes to the test.
What's good for one person is not necessarily good for another. You do what is good for you. Just make sure you're going to be able to understand what you're doing when you're taking the test. You should be able to look back and see what you did.
Yeah.
Okay, folks. Number 4. This one is short, but if you don't know how to do this, the calculations with variables, this might give you a problem. Write the formula for the area of a circle A in terms of its circumference C. Okay, so I need the area in terms of the circumference. Okay, so the area of a circle, start off like this. Circumference of a circle. Now, on the actual test, they probably will go the opposite way. They'll say, give me the circumference in terms of the area. You still need both the formulas. Okay, so basically I need to end up with A equals. On your test, you're probably going to need it to say C equals. And then you're going to have to substitute in whatever you have here for D. But I'm going to do it the other way. Okay, I'm going to say that C is C divided by pi, if I divide by pi on both sides, is equal to D. But the radius, 2 radii equal 1D. I need radius so that I could plug it in here. When you do it, you're going to need diameter, so you're going to have to do it the other way. It's like we're doing the problem in reverse of how you're going to get it on the test. Okay, so the diameter is 2 radii. Multiply by 1/2 on both sides. You have solved for R. Okay, so this is C over 2 pi. 1 times C, 2 times pi. Why did I do this? So that I can now go to this one and plug in for R what I have. So area is equal to pi times R squared. Now for R, I'm going to put C over 2 pi. You cannot stop there. Let's see what happens when you square this. Okay, write it out if you need. 2 pi, C over 2 pi, 2 of them. Okay, multiply more. C times C is C squared, so you have pi here, and you have C squared, and you have 4 pi squared. Now what happens? This pi and one of those 2 pi, this is pi times pi. This pi cancels out with one of those pi's. And this is your answer. Now, these are the notes you have to work with. Are you able to do it the other way around? You solve this one for R, okay? And then you have to turn R into diameter, and then you plug that in for diameter here. Would you be able to do that?
Why did you write 2 pi's when it was like 4 pi pi? 4 pi pi?
What's 2 pi times 2 pi?
Yeah, it's 4 pi, but then you did.
Not. No, it's not.
No, oh, okay, sorry.
It's 4 times pi times pi.
Yeah, it's okay. Sorry, that was wrong.
No, yeah, definitely. See, the thing is, I know that this is hard, guys. I know. And you might be thinking, why are you giving such a hard test? Well, because I'm showing you how to do it. Okay? And you know what? I know that this is still hard going the other way. This might not make it easy. So let's go ahead and do it the other way, just in case it is the other way on the test.
Mr. Rosenthal,
Mm-hmm. Take good notes, folks.
where did you get 4 times pi times pi?
You waited too long. I already erased
No,
everything.
yeah. How did you get 4?
I
The
had
last.
this. That's what the radius was that I solved for over here.
Yeah.
So when I plug that in here, you get c over 2 pi squared. That is c squared over 4 pi times pi.
And then it was c, and then the last one that you made a square.
But it was all times this pi here. So that pi canceled out with pi.
Oh, okay.
Okay, write this down, everybody. Here goes the other way. Now you want to write what c is equal to in terms of the area. So now you need to find out what can you plug in here. It would be for the diameter. Okay, so area is equal to, let's divide by pi. Area divided by pi is equal to r squared. Okay, square root both sides. R is equal to the square root of the area over pi. Okay, now, if 2 radii equal 1 diameter, all right, then I need 2 of these to make 1 diameter, right? So what I would do is I need 2 of these. So I need to double both sides. Now I have a diameter, and it's going to be 2 of those. This is probably what you're going to be doing on your test. So now I'm ready to substitute for D. Circumference is equal to, all right? You could probably leave it like that. I would just group the pi with the 2 because they're both are outside of the radical. So I would say 2 pi times the square root of a over pi.
Wait, what were you trying? What? Okay, so the one before is the one on the review, but then this one, this is the one that's probably going to be on the test. But like, what were you trying to find?
They wanted the
phrase it like the question would be phrased.
Write a formula for the circumference of a circle C in terms of its area A.
Okay, thank you.
Mr. Rosenthal, how did you in the first line of red under the C equals D pi, how did you get that? How did you convert that from the equation before?
Which one?
The first red line under C equals D pi. How did you get to that?
Oh, that was after this.
Yeah. So how did you convert it?
So did you get how I got this?
Yeah, you multiplied, but you doubled it.
If that's what D is, then I can substitute this here for D. That's what you see right here.
Oh, got it. And then you just simplified it.
Sure.
Okay, thank you.
All right, so you see this? This is D. Just follow this. It's right there for D.
Okay.
And then don't forget there's a pi there. Now, in future classes, you can go further with this. You're not allowed to have a fraction inside of a square root. We get rid of it a certain way. We get rid of it by doing this. What is anything over itself? It's 1, right?
1.
So this is more advanced stuff that you're not responsible for. So this would become square root of A times the square root of pi is just going to be the square root of A times pi. And that's okay. The square root of pi times the square root of pi is just pi. And that would cancel out with that pi. So then the circumference would be 2 times the square root of A pi. By the way, these are real formulas. If you had the area and you multiplied the area times pi, took the square root and multiplied it by 2, that's the circumference.
Mr. Rosenthal?
Yeah.
I'm confused. So.
Okay, let's go back to the beginning. What did I do first? I divided by pi on both sides because I wanted to solve for r. I want to isolate r.
Yeah.
So I get rid of pi by dividing. Now it's over here. But that's r squared. So
why'd you put the radical sign or whatever?
Because r squared is equal to that. I want to know what just r is. So to find out what r is, what?
Where did the radical sign come in?
I was explaining it to you just now.
Oh, sorry.
Look, once I divided by pi, that's what it looks like now. Well, that's not what r is. That's what r squared is. So what you do is you take the square root of both sides, and that gives you r.
Oh, okay.
Right? If this was 25 and I take the square root, I'm going to get 5, right?
So in order to get rid of the square, you take the square root, and then now it's 2
now
times?
It's just r. It wasn't 2r. Okay. It was just
Where
that.
did the r go in the last equation?
I'm going to show you right now. So I had this, right? Now, 2r's is if I multiply that side by 2, then I have to multiply this side by 2.
But you can just, where'd you get the 2 from? You can just multiply it by 2?
Because I know I needed to substitute for diameter. And I saw here, I need 2 radii, not 1.
Oh, okay.
So I doubled both sides to get 2 radii. Okay? The other way
thank you.
The other way
the r is gone. It's not in the equation anymore after that.
Yes, okay, so look. This here is diameter.
Diameter isn't in the equation either.
Hold on, did you see what I just did? 2r is diameter. See it?
Yeah, but that's not in the final equation.
Wait. Hold, you see it? Diameter is equal to this, right?
Yeah. You're substituting for diameter.
Hold on. Wait. So this goes in there for the diameter.
Oh.
There you go. It's substituted for diameter.
That's why, like, when you substitute, the variable isn't there anymore.
Correct. I know that this is tricky for you guys.
Wait, I got a different answer, and I tried it, and it still worked. I got C equals 2A over R.
So, Mr. Rosenthal?
No. Wait. Circumference equals 2A over R?
I tried it with like some, just like with some numbers. And
okay, here we go. Okay, here's A. Here's area down here is pi r squared. 2A is 2 pi r squared. Okay, and then if I divide by r, yes, that would work. 2a over r is equal to 2 pi r. So circumference is 2a over r. That is an answer. I don't know how did you get to it?
So first we wrote the equation as a equals r times pi, then divided by r on both sides. So I got a over r equals r pi. Then I divided by pi, and I got a over pi equals r. Then I multiplied by 2 because diameter is 2 radius. And then since we multiplied by pi in our circumference equation, the pi's canceled out. So I got 2a over r.
Okay, so this is not incorrect, but when that question says that it wants it in terms of area, then your variable has to be area. You can't have 2 different variables when it says it that way. But that doesn't mean that this is false. It's true that this is the case. Okay?
And so the question for this would be, find the equation for circumference in terms of area.
Write the formula for the circumference of a circle C in terms of its area A.
Okay, and that would be like the one that's probably going to be on the test.
Yeah.
Okay, thank you.
Mr. Rosenthal?
Uh-huh.
Before you erase it, so you went from D equals 2, 2 square root of A over pi.
I plugged it in for D in the circumference formula.
So where?
And then you can leave it like that. You can just leave it like that, would be fine. I rearranged the pi with the 2.
I'm just confused how you got C, because where's the D pi?
That's the formula for circumference.
Yeah, I know that, but like, how do you get the D to, like, how do you switch them out?
Okay, so that's what I was doing over here. Area is in terms of radius, okay? Because area is in terms of radius, I had to get radius solved. Then I had to think, well, a diameter is what they use here. I need 2 of those, so I doubled both sides. And then I said, oh, so the diameter is 2 of these. So then I can say this diameter is 2 of these. And now I'm done.
Oh, so you plugged in 2 square root of A over pi for D, and
yes.
then that equals C.
Yes, times the pi, of course.
Yeah. Okay, thank you.
I went one step. You could stop here. I put the pi using a commutative property. I arranged the pi with the 2 pi. Okay? In algebra, you go one step further and get rid of the pi on the denominator of the root by doing this, and you would get this.
So we don't need to do the get rid of the denominator, right?
You do not need to do green.
Okay. And also, it's like this problem is basically we just have to use diameter in an equation where diameter is equal to something.
There's if you can manipulate using algebra geometric formulas and making the relationship between them. It's a very important skill. It doesn't necessarily go with geometry, but they're piecing the two together here. So the reason why these tests are good, I know that they're difficult, is it's because it's asking you to understand on the deepest or on the deeper levels of understanding. Okay, you guys are going on to algebra now. All right, if you can do these problems and work your way and manipulate them, you are on your way to really mastering mathematics. Okay, let's move on because we're almost out of time here. Cell phone users. Hopefully you guys took really, really good notes. All right, cell phone users can obtain a clear signal when they are within a 30-mile radius of cell tower A. I'm going to put a point, label it A, and I'm going to draw a circle around that point. And that's my cell phone tower A. And I'm going to draw a radius. And my radius is going to be 30 miles. You should be doing the same right now. Okay, the radius that cell tower B covers is 1/4 this distance. Okay, so I'm going to draw another circle, smaller, and the radius for B is going to be 30 divided by 4, which is 7.5 miles. How many times greater is the area of coverage from cell tower A than from cell tower B? Same idea that we've already done. Everybody take a look. We're not going to spend a lot of time on this. Okay, one-dimensional radius to one-dimensional radius. This one is 4 times, so 30 to 7.5 is a 4-to-1 ratio. Okay, it's 1/4 the distance. How many times greater is the area? For area is 2 dimensions. So what you're going to do is you're going to take your 4-to-1 ratio and you're going to square it. What does that give you? 4/1 times 4/1.
16 to 1.
It's a 16 to 1. It's 16 times. 16 times greater area. Done. This problem should be fast.
I have a
4 times the radius, that's 1 dimension, then it's 4 squared the area. What do you think the volume would be if it was a sphere? 4 cubed the amount of volume, right? Which would be 64 times the volume if it was a sphere.
Are you saying when you find the area of that circle and it's 30 times
it's 4 times the radius.
4 times 30? Yeah, okay.
No, not 4 times 30. This radius is 4 times that radius. Because the radius is squared and area is a squared, right? It's 2-dimensional. Then it's the square of how many times greater the 1 dimension is. It's 4 times. That squared is how much more the area is. How many times greater the area is.
So the cell tower A or whatever has a 16 times greater area than cell tower B.
Yes.
Okay.
Other questions? I'd like to work on one more problem before we break. Now we're starting to move a little bit. Finally getting some momentum here. Okay, last problem for today, number 6. A circular...
How many problems are there?
I don't know. We can take a look, but let's see.
18.
Yeah, 18. So we're only a third of the problems, but that doesn't mean all the problems are going to take as long. Some of those were very complicated. You know, we didn't do a lot of practice for that stuff. Okay, a circular cover to a septic tank has a diameter that is 4.5 times the diameter of the cover to a water well. Oh, this seems very similar. If the area of the septic tank cover is 40 square feet, what is the area of the water well cover? Okay, this is very similar to the last problem. They're just taking it one extra step. Okay, so let's see. So as it 4.5 times, so diameter of septic tank is 4.5 times the diameter of water well. Okay? And then the area of the septic tank is 40 square feet. Now I'm going to go to my screen. Okay. So what they're saying is the diameter of one is 4.5 times the diameter of the other. The way that you don't need to write it this way, you can say that in one dimension, it's 4.5 to 1 ratio. In 2 dimensions, for area, what would it be? 4.5 to 1 squared is going to be the relationship. What is that going to be? 20.25 to 1, the area relationship.
Could you reread the question?
A circular cover to a septic tank has a diameter that is 4.5 times the diameter of the cover to a water well. The area of the septic tank is 40 square feet. What is the area of the other one? So what I first want to do is I want to find the ratio between their areas. I already know the ratio between their diameters right here, 4.5 to 1.
Okay.
So the ratio of their areas is not 4.5 to 1. You have to square that. It's 20.25 to 1. Now I can set up a proportion. 20.25 to 1 is 40 to what? To x. Okay. All right. So then you can use cross products if you would like. 20.25x is equal to 40. Divide by 20.25. And that will give you the area of the water well covered. 40 divided by 20.25. 1.98 about. Oh, round to the nearest tenth. Well, then it rounds to 2.0. About 2.0 square feet. Done.
Wait, what did you do with that? Did you cross multiply?
Yes. This times this has to be equal to this times that.
And
then I
why is it, oh, but why did it say 20.25 over 20.25? Where'd you get the other 20.25?
Once I had this, I divided by 20.25 on both sides to get x by itself.
Oh, okay, I get it now. Okay, thank you.
2.0 or, yeah.
That's my answer.
Is that 2.0 or 20?
2.0.
Okay.
Okay. All right, so you guys can stay around and ask me more questions about this, but you're dismissed. We'll continue the review tomorrow. If we don't finish the review tomorrow, we'll have to push our test to Monday. Okay?
Thank you, Mr. Rosenthal.
You betcha.
Mr. Rosenthal,
Thank you.
You bet.
Bye.
Thank you.
Okay.
Wait, what day is the test?
we would have to push it to. Wait, Mr. Rosenthal,
It's Friday, but if we don't finish the review tomorrow, then we'll have to push it to Monday. Be ready by Friday.
Mr. Rosenthal, so are there no classes on the 2nd, 3rd, and 4th, or the
3rd and 4th?
just the 3rd and 4th? Okay.
So we're good on a test day. If we have to move to Monday, we're fine.
Yeah.
Yeah, I'm not worried about that.
On homework for 12:10, the last one about cones and pyramids, it's all regular pyramids and cones, right?
Correct.
Okay, cool.
Now these problems are a lot more complicated than I thought they were going to be for the test.
Yeah, they really want you to know it. You have to connect a bunch of different ideas. It's not just find the area, surface area, and find the volume.
It's kind of like STEM, like that one problem where you're supposed to do the algebra instead, rather than surface area and stuff, because you're combining like two different things. Yeah, so I think that's good.
But it looks like on the back page of this, the problems become, like I think we're going to possibly get through the review tomorrow. The problems start to lighten up on the back side. I don't know if you're looking at it. Name what the figure is called. That's one number. It's just like an octagonal prism. How many vertices and edges make up the figure? You're just counting how many there are. That's easy.
1, 2, 3, 4,
Identify
5.
the shape resulting from a horizontal cross section. That's easy. Draw a side view and top view of the image. Easy. So the back side of this is going to be, you're going to be jamming on the back side. And then there's a word problem about cylinders. Okay. Having to calculate the height of a given other information. That's a weird question. Are spheres polyhedrons? I'm curious to see what the book says the answer is to that. We talked about spheres being polyhedrons of infinite faces, right?
We could look that up though, also easily.
Yeah. We can ask. You can look it up while you're taking the test. Are spheres polyhedrons?
Yeah. It kind of reminds me of Chinese, because like in Chinese schools, you would learn traditional. That's like a bit harder, and then after that, you learn simplified, which is kind of easier.
Mm-hmm. It says no. It says a sphere is not a polyhedron.
Okay. Go ahead.
We use that idea to try to understand how we get those formulas. If it had infinite bases, but it can't have infinite bases. It either is one or the other, according to this. So let's see, composite solid. We have to find the volume of it. That's straightforward. That's not a tricky one. It's just, can you find the volume? And then one of them, they give you the lateral area of a pyramid and the slant height. And can you find the dimensions of the base given that information? If the dimensions of a sphere are quadrupled, what effect does it have on the volume? Oh, we just talked about that now. It's going to be, if it's quadrupled in one dimension, then it's 4 to the 3rd power in 3 dimensions. It's going to be 64 times the volume. We already did that. And then the last question. A cylindrical water storage tank contains a certain amount of water volume. All the water is pumped equally into 3 congruent cubic coolers. What is the minimum length that each cooler needs to be? Okay, that's a fun problem. We did a problem where we took a container and filled up 3 other cylinders. Now we're going to be filling 3 cubes. All right, well, I think the backside is a much different type of thing than the front side. Any questions? Looks like you'll have to find the surface area, estimate a surface area of some weird looking object. Look at that, number 14. Estimate the surface area of that object. Looks like you can treat that part where my mouse is as a half cylinder. The 20 here shows you how far it is up to this breaking point here. So then you can treat that as a rectangular prism. And then you can have these little, this top part here, you know how tall that is. So you can find the volume of, or the surface, oh, that's surface area. Wow, that is a beast of a problem. That is an interesting problem. I'm gonna have to think out that one. That is a weird looking shape. Wow, they're going tough on you guys. I'll have to be creative in my grading here. 14 will probably be a bonus. Does anybody have any questions for me? No? Hello? No? No questions?
I don't think for today. I have another lecture in like a couple of minutes.
We all have to start working on number 14 ahead of time.
Yeah.
Yep.
Oh, wow, that's a weird shape.
That is really, really weird. Yeah.
It's like in the center, it's a rectangular prism with a half of a cylinder on top, and then on the other sides it's thinner cylinders.
Well, how are you going to know what this is? Look at between that cylinder there, that half cylinder, and the wall. How They don't tell you that distance.
Let's just estimate the surface area.
Yeah, but how do you, that part of that is
yeah,
part of the
that's
surface
weird.
area.
Yeah. They don't tell you the radius. Oh wait, no, the radius.
You can get the radius of that circle because, you know, let's see.
Huh.
Oh yeah. Okay, so look, see my mouse? This is 30, right? All the way to the top.
Mm-hmm.
But to that portion there is 20. So that means from here to the top of the cylinder, which is the radius, is 10.
It's 10 millimeters.
So we know that. Also, the distance from the center line to here is 10. So which leaves 20 here and here. But it doesn't tell you that this little piece and this little piece down here are split evenly 10 and 10. Oh no.
Yeah.
If this is 10, then what's left is 5. So this would be 2.5, 2.5. You would have to assume that they're 2.5 and 2.5.
Yeah, that's the thing, because like in the homework, when we were supposed to find, I think it was the volume or the surface area, it was really hard, but like I just took a ruler and I measured, and I kind of just like estimated how long it was, because they were like the same length, even though it didn't appear to be. Like two sides, like one that they gave you, but there was one that you needed, but they didn't give it to you.
I'm just wondering why they would put a problem like this on the test when this is a very, very complicated, time-consuming problem. I don't understand what they're trying to get out of that. I mean, I don't need you guys to know how to find the surface area of something so complex like that. So I'd rather you guys just show me you could take the surface area of a rectangular prism and a cylinder.
Yeah.
Anyway, I'll figure something out for that problem. I wonder if the one on your test looks like that. It might look different.
Well, like, aren't the retakes harder than the actual test?
I hope so.
Yeah.
Is
So
that what
maybe
people
these
say?
problems. And like I thought that's what it was, because like if the vocabulary was like, if they didn't give you the vocabulary words,
That's different. The vocabulary is it doesn't come into play now.
Oh.
So it's just a matter of 3A versus 3B. Is 3B harder than 3A? I don't know.
Maybe it's this figure, but it's but like minus the like those prisms on the side.
Okay, well, if nobody has any questions for me, I think that will stop our video now.
Okay. Thank you, Mr. Rosenthal.
You bet. If anybody has questions, now's the time, because I'm going to end the meeting.
Thank you, Mr. Rosenthal.
Thank you, Mr. Rosenthal.
Okay.
Bye.
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 Bye.